Today we will do the text classification using the built-in commands. Okay, using the deep learning toolbox. If you remember, we had done one project, mini project, which was about the text classification only, but it was not classifying something. It was trying to fill out the blank spaces. The correct, if you remember. So that was a project. But today, what we do is slightly different. Okay, so as you can see here, we have a file that is factory report.csv. It's a database. I'll just open and show it to you. Okay, and okay, let me just bring it up. Yeah, can you see now? Right, so as you can see, it's a text data, right? We have a description, we have which category, uh, in the sense what type of it's about a factory's failure report, right? And what type of failures do occur, it's the first column, that's a description. All right, and various types of sounds, right? What exactly happens with that kind of problem is given over there. Okay, that's the description of the things. Then we have which category, which department, or something like that. You see, category is mechanical failure, electronic, leakage, right? Software, right? Various these things we have. Then how urgent it is, right? How quickly you need to address that. That's what you have over there. And then we have another category for the resolution. What you should do in order to, right, overcome the problem, and what will be the cost. Okay, cost of the repair, right? So this is what we have as a data, right, in this. So the overall data size, if you want to check, that will be around 480 various parameters. Okay, 480 rows, and if you see the number of columns, A, B, C, D, E, so 5 columns, right? So the data set is arranged in this particular format. Now let us try to do the classification of that, right? Whenever I give a new data, it should be able to classify or identify what type of error it is. This is what is my target. Okay, right? Again, we are not going to write the basic programs right here, right? We'll try to use as much as possible the built-in commands, because we are very familiar with all types of commands by now, because we have done more than 5-6 mini projects, right? Okay, so let me start with the edit. Let's say text. So we'll open a new this thing, and I'll open right. Let's go to the, let's insert a new section here, and in that section I'll open this particular file. Okay, so file name is equal to, I'll give it's a string data, so double quote, it's factory reports dot csv. That's the file name, and I want to read the data. So data present in that file, it's a, if you remember, there is a command called read table. Okay, from again, this is directly taken from the fundamentals of MATLAB, that class. Okay, I want to read the file name, whatever the file name, read that, and you have to say that what type of data you want, right? So I want the data to be in the string format, so you have a specifier, that is text In a sense, you can read every character by character, right? That's possible, but I don't want to do that. I want to go with the string. Everything will be put up in the form of a string. Then you can see a part of the data, right, whenever you require. So that can be done using head of the data. Okay, let's try to run this part of the code and see what we get. So you see here, so we have data present 480 into 5, right, which is there in the thing. I can actually double click and open and see that, right, whatever we discussed earlier, it's there. 5 columns, 480 rows. Okay, so that's the data. Again, since the head shows the first few data, right? So first 8 data you can see. Okay, complete, right? So 5 columns. That's what is the head going to do. Now I want to check what are the various categories in my data. So it's actually a pre-processing step. Directly you can do that. So data dot category is equal to, I want to put it into a category. So categorical of the category. Okay, so now when I run this code, I will be able to see a new thing called data category. So inside the data, I will be having a categorical value as well. So that's here. Okay, data dot category. Okay, it gets converted into a categorical format. That's all. All right. Then in the next part, let's move to the next part. So I will go with the, okay, let's see the categorical data and how to visualize the different data and what is the frequency of each of the category. I want to visualize that. So I'll open a figure, then directly go with the histogram, right? Remember the various plots of supported in MATLAB in which one of the type was histogram, right? Data dot category, and I want to give an X label, right? So say that I want to say it's class, which class it belongs to. That's what is along x-axis, and y label, say frequency. Then let's give a title to this. So it's class distribution. Double quote. Okay, so let's see now what happens. So this is actually the preparation of the data, and I will be able to see that uh, it's getting displayed. So so as you can see now, right, we are going to get a display. Okay, so the display is basically how many, what is the frequency of the data corresponding to each class. There are 4 classes. One is electronic failure. So it's how much? Can I read the number here? Yeah, you can actually click over there. 168. Okay, 168 corresponds to that. 68 corresponds to the category leak. So 204 mechanical failures, and you can see that 40 software failures. Okay, that's the detail of the data set. All right, let's proceed further. I will add a new section to this. Now I'm actually starting with the pre-processing of my data. Right? So it's a text. If you remember, what was the major issue we faced when we wrote a code in other NLP project, the text processing project? Try to recall what was the issue and how we solved that issue. Okay. How do you see? Our goal is to process the textual data, correct? But how good are our machines, like it's a computer or a processor, microcontroller, whatever you have? How good are they handling the text? How good? In the sense, whenever we try to when see, the machines are good in handling numbers or text, correct? So you see, I have text here, right? Somehow you need a method to convert that into the uh, num- text into the number format. If you remember, we converted everything into numbers over there, right? We had a huge data set, and we converted the data set into numbers, if you remember, right? So that project, try to go back to that project once again when you have time, because there everything we wrote from basics. We never used any inbuilt commands. Okay, so I suggest you to go there, because there you understand the from scratch how to write by ourselves. But right now we are not doing that. Okay, so the fundamental idea here is that I cannot use the textual data as it is. You need to convert. Okay, so that's a fundamental idea, right? Okay, we'll do that. But before that, now uh, I'll start with the pre-processing part. So in the pre-processing part, my first objective is that I want to divide my data set into training and testing part. Okay, so I'll define a variable called, say, is x is equal to, right? We use what is called as a partition, right? I need to partition my uh, data. So I will use a built-in command called cv partition. Okay, let's see, right? You can create, right? There is a command which can perform the partition of your data using a random generated. It's actually cross validation partition of your data, right? We can do that. So we had never seen this, so I wanted to show you this is possible. So I'm doing it in a different way today. Okay, so cv partition, right? So do the do it with the data category, data dot category. That's what I want to do this. So there is an option called hold out, how much you should retain, right? In a sense, you should retain that for your testing purpose, correct? Testing or the validation purpose. So, right, so there's a keyword, hold out, hold out, comma, in percentage we talk about, right? It's a 20%, so 0.2. In the sense, 80% you will use for the remaining 80%, remaining 20%, sorry, will be used for the testing purpose, or the, we'll keep it as a validation. Okay, so data training data, right, is equal to, right, in your variable called data, right, from this data you read the 80% data, correct? So that is, anyway, it is done at a random pattern. So data of uh, it will actually, okay, let me run this and show you what exactly is going to happen, then I'll continue this. Okay, so I'll just run this part of the code. So you can see X will be created. Okay, you can see X. So X actually has, right, you see two variables are created, correct? One is called as a train size, and one more is called a, right, test size, right? So that's one thing. Again, I'll show you. That is everything will be okay. 384 will be the training part, remaining 96 will be for the testing part. So test set, the type, etc. will be created over there. Okay, now what I do, I split them into training and the testing part. Okay, so uh, data string is equal to, from the data, right, create a new variable called training of uh, how many variables I want the X variable. Okay, X variables, X number of entries, all the columns. Okay, that will be for the training. Okay, that's done. Now data for test is equal to, once again, from the variable data, test, do the test of uh, the same number, right? So the number will be the X itself. Okay, test of X. Already we have seen that how many numbers are for training, how many numbers are for testing, we already know that. It's already present inside that variable X, so you can directly access that. Comma, all the columns, close this. Okay, now you see when I run this, right, you see the data training and data testing are automatically created. You don't have to, right, separate it by using any other. So that's what is the advantage. We have never used this so far. I'm teaching you how. Okay, so that part is done. Now let's go ahead. In the next part, I'll try to extract the text data and the labels from the this partition. Whatever you have done the partition, you divided 480 into 384 for the training and 96 for the testing. Okay, for each of them, I need to extract what is my data and what is the label, right? Because you give a textual data as input, machine should classify, okay, this belongs to a particular problem. What are the problems possible? Electronic failure, leak, and mechanical failure, software failure, like that. Okay, right. So let's take the text data. Text data for training is equal to uh, let's open the data training. Okay, you see, let's open the data training. I open the data training. Where is the data? Data is present inside what is called as a description, correct? It has a heading called as description. On the top you can see the, right, the name given to that. So I have used that to access this. So text data for training is equal to the data training dot description. Okay, so data, this thing for description is fine. Similarly, I'll go for text text data for testing purpose. Where is it? It is in the other category, that is data testing dot, Are you okay? From that I pick up. Right. So where is it? Go to the data testing, double click on that. It will open up this thing. Here, out of the 96, I can, right, collect anything. Is it okay? That will be the testing data I am supposed to give. Now I need the the y value for the training. It's actually the actual answer. Y like y y train is equal to data train dot. Let's open and check what is my answer. What's your answer? Answer is in the category, correct? So this is what is the answer I'm expecting, correct? So is it a mechanical failure, electronic failure, leakage, or software, etc.? I want to check that. Correct. So that is present in which one? It is in the category. Okay. Similarly, y y test is equal to data testing its category. Are you okay with this? Now I'll show you another graph which we had never seen. Right. That's by using the word cloud properties. Okay. You can call a figure and word cloud in the sense which word is highest used, it will be bigger, right? Depending upon the usage, depending upon the use, the words you have in your database, you can actually plot a word cloud. Okay, so that is uh, text data training. All right, this is what I want to give it title called training data. Okay, let's quickly run this part of the code. There is a mistake. What is that? Y train is equal to data. Oh, okay. It's not data, right? It's a data training, I guess. Data training and data testing. All right. Let me clear that out and let's run this part of the code. Okay, it's going to take some time because we are trying to plot a word cloud. So can you see the word cloud? So this is called as a word cloud, right? Which says you can see that the word highest used highest is mixer. Okay, and slightly lesser assembler, agent, scanner, sound have been used slightly lesser time. Then outside that you have a bold black color that's slightly lesser than that. Okay, right? Fuse, blender, controller, appearing, coolant, spokes, right, etc. Power, right? And as you see the size getting reduced, that means they are used but lesser in number. Okay, so the word which you see outermost are very small, right? So those are the lesser used words. This plot is called as a word cloud, right? How do you do that? You just call by you call the function to plot that. It is called as a word cloud, and pass your data which you want to check. Okay, so once we do that, we will get this. Now I start with the actual pre-processing part. Here I just verified. I try to get more details about my data. That's all. All right. So now let's proceed further. I want to write what is called as a pre-processing part, but before that, I'll use the command directly. So uh, let's try to do a tokenization. So that is doc train is equal to, in the sense, uh, for a training data, I need to process it. So pre-process text. This program is not there. I have to write it. Okay, it's a function, right? I need to do this for uh, text the text data for training as well as the text data for the testing. Once I do this, and I'll do this doc testing. Let's just a test. Doc test is equal to pre-processed text. Okay, the text text data testing. Okay, right. So we have done that. Let's see, we are using it now. And oh, okay, let me write that as well. All right, so pre-process text. I'll just edit that part. So let's do that. So what we are going to do, what are the various steps that we are supposed to follow to write to do the pre-processing? I'll tell you now. So first thing is a split the data into tokens, like split them into individual words, convert all of them into the lower letters and remove the punctuations, right? If you remember, these were the pre-processing required, right? Same thing we did earlier, but now we are going to use built-in commands here. Okay, right. Okay, so this is what we do. Okay, function, it's a function. Now what it returns, it returns a d function. D is equal to, called by the same name, it's a pre-processed text of some data which we pass, which is t. Okay, in the function. So my first operation is that I'll do d is equal to, right, there is a function called tokenized document. Okay, so we'll see that. Tokenized document. So you see here, the tokenized document is, right, array of the tokenized documents of a text analysis. That's what you are going to get. In a sense, ultimately you see, I'll directly go to the, right, you see here, hello world is my input data, right? You get hello, then world, and then this. Okay, so ultimately you will get a different number of words present in that's what we are going to get as output. All right, so d is equal to tokenized document of, right, the t, whatever text I pass, I'll do this as my first job, right? I get this. Now next is that every letter I'll try to convert that into a lower letter. Okay, so d is equal to okay, I'll show you another function. You don't have to write you don't have to write a customized function here. Directly you can use it. Okay, so that is help lower. Lower is a function which converts the data into the lower, converts to lowercase. Simply pass the text you want to pass and it will get converted into lower. Okay, so this is lower of whatever d you have, convert that itself into the lower. Okay, that's the second step. And what will be the third step? If you remember, any punctuation mark you have, you need to remove that, right? So there is a function, it's called as erase punctuation. So you see, erase punctuation is a function to erase the punctuation from text and documents. So let's use that. So d is equal to, see, d is the one which I'm going to return, so I keep d as it is in my variable list. Okay, So this is erase the punctuation from D itself. Okay. So if you try to recall what we had done earlier, there we had to write each and every function. Yeah, we had written the function completely. We had written so how to do a tokenization. Yes, we did that. Then, right, we wrote another function to do a lower letter conversion. Erasing of the punctuations also we wrote complete different functions. All functions are there, right, in your the drive, right? Okay, but now you don't have to do that, right? There are inbuilt functions to support this. So simply call this pre-process, right? So text data, sorry, text, sorry, pre-process text is the function which we have written now here that will do this job. Is it okay? Right. I will show you what happens once this gets done. I'll show you that. But before that, okay, let's run this. So you can see the doc train, doc test are there. So if you open the doc train, tokenized document. See, it's actually a string. Items are occasion. Everything has been separated. There are 9 words in that. Okay, so like that, it actually uh, converted the complete data set into the tokens. All right, fine. So now let me show you uh, the doctrine. I'll just try to see first few things. So 1 to 5. So you see, we have 9 tokens. The same thing which I tried to show you, right? Same thing is there, but it's actually in a different format. Okay, so 10 in the second data set. The third, fourth, and fifth are like this. Okay, now you see, now we come to the another part. So I just erase this. I don't want to see this. Right? I just wanted you to see that it's getting done in the following format. What I do, I'll try to comment this. If you want to see this when you run the code, just uncomment. Right. So now I'll go to uh, uh, the word encoding part. Right. Conversion should happen. Right. I should convert the data tokens into the numbers, correct? So again, if you remember, we had written a big function for that purpose, right? Conversion of text into the numbers. But now it's not required. Again, I have a built-in command to use that is called as uh, word encoding. Word encoding model maps words to indices, and whenever it is required, you can come back as well. You can even come back to the right original system. All right. So that's what we are going to do now. We are going to use the word encode. ENC is an encoder. uh, word word encoding of. I'll just do with the doc string. And now, okay, let me visualize. Let me make another visualization over here. Okay, but anyway, before that, let's run this part. Do I have a ENC here? Yes, there is a ENC, right? You can see that these are the various words present over there. Okay, and the vocabulary has, you see, overall in my the complete data set, I have how many words you have. You see the words are 428 words. Okay, and what are the four? Do you remember something very similar to this we had done, right, in our previous one? So I remember showing how the words are getting converted into the numbers, which position is the this number locates. We had, right, I had shown a very similar this thing to you. So you see that, right, every number gets an index, right? So item has index 1, R index 2, occasionally index 3, and so on. So that's what is the encoding that has happened so far. Okay, so let me add up anything. I want to visualize, right? I want to have a different visualization. So for which I will create the doc length variable, right? Okay, doc length I cannot use because there is a command by the name. I will write it complete. Okay, so I'll show you what I meant. So there is doc length. Okay, doc length of the document in the document array. So every length it can be calculated. Right? So this is uh, doc length of, right, the document tree. For this, I'll go for a create a new figure and I'll go for a histogram. I'll do the histogram of the document length. All right, give a title for this. Title is equal to the length of the document, and X label is going to hold the count of lengths, and Y label will be the number of documents. Number of documents. Right. Okay. I hope this comes up. Let's check. Right. So you can see that. So the horizontal axis is length. No document has length 0, 1, 2, etc. Right? It's something starts like 4. So 3 there are 30, 4 there are around 45 or something. Maybe I can. So you can see that this is the length. So right. So 79 documents have this length. 87 documents have this length. Okay, I have length 6, so I can actually do the same here. So right, length 8, 27. So length 9 is this, length 10 if you want to calculate. There are 12 documents whose length is 10, and so on. Okay, so and the highest one you can see here is this. So there is one document length is 15. Is it fine? So again, you can easily get it by using histogram. I hope this is fine for you. Shall we proceed? Okay. Now, so I can see that most of the text here have length equal to or less than 10, right? More than 10, there are very less what you call documents, right? So very less documents show a length equal to or greater than 10. Just see now once again, right? So from this, it is very clear that, so most of the documents, right, more than 80%, 85% of our documents have highest length equal to 10. So I want to fix the length of the document to 10. Is it okay? So let's do that, right? That saves a lot of calculation, right, from the machine side. So This is the next section I'm going to create, and let's do that. The sequence length, let us fix it to 10 tokens. Maximum 10 will be processed. More than 10, it will be neglected. Okay, so X training data X equal to, so you see, I'm going to use a command called document to sequence. All right, so doc to sequence. Convert the documents to the sequence of sequences, right? Just for the deep learning purpose, right? Document into the sequence, it will get converted into that. So it's going to use you have to specify which type of encoder you are going to use. The encoder is already present here. You can see that the ENC which we had created earlier, right? That actually is the encoder. So we will call it in this fashion. So document to sequence, pass the encoder enc, right? So where we created the encoder, just recall, so that is word encoding, correct? Here, after performing the word encoding, we obtain the variable called enc, which is the variable name for the encoder, correct? Enc, comma, you have mentioned which is the data set that you want to perform this. So I know that there is what is called as a doc train, correct? So doc train, comma, specify the what is the maximum length. Length will be equal to this sequence length. I can also write 10 directly here, but if I simply write 10, people don't understand what I'm trying to write. Okay, so that's why I kept a variable name by that name and I'm using it. Okay, now you see the x train of, I want to see all the data set from 1 till say 10. First 10 data I want to see. Okay, let's quickly run this part to see. You see, everything is right numbers, right? Every data got converted into number. Can you see? So that's how we converted our data into. So you can see here, is it what type of data it is? It's a cell array, correct? So that's why it's showing that in the details part, it's a cell array, cellular array. So cells having, okay. Okay, similarly, I am supposed to do the same operation with the, so with the with the test data as well. So what I do, I'll hide this. I don't want this to be shown. I just wanted you to visualize once, so I did that. Next, I want to do with the X test. Do the same thing. Doc to sequence. Use the same order, but don't pass the doc train. Pass the doc test. Keep everything same, right? Don't change anything. Don't change even the length. Keep it as a sequence here. Okay, so that converts. Now the data set is ready for performing the training, testing, or the validation. All right, so we'll move to the next part. Right, okay, it's now you see that each line in my database is the data, correct? Is one training data or a testing data. So what should be the input size? Input size is equal to 1, because at a given point of time, you see, this whole thing will go into your machine at a point, right? At a given point of time, the complete data like this will go into the machine takes this as input. So one single data point will be passed, and that will be something like this. It has to look into that numbers, and the machine needs to classify which category this belongs to. Okay, so input size is equal to 1. Now there is one layer coming into picture, that is whenever you are processing the words, we need to uh, uh, use a layer called as word embedding layer, right? It should specify what is the dimension. Okay, so that embedding dimensions is equal to, let me say, it's like number of hidden layers over there, hidden neurons over there. And then I'm going to use the uh, actual CNN layer. In this case, again, it's a sequence of numbers, right? Which is the best suited uh, neural network or a deep neural network for a sequence of numbers? If you remember, try to answer that. We have used that already, and to predict the stock price, which was the uh, which was the hidden, which was the type of deep neural network used over there? I think we used LSTM, right? That's the one which is very good in predicting or performing the regression of the time series of data. In a sense, series of numbers. Whenever you are dealing with a series of numbers like this, right? Just see here, right? It's a series of numbers. Whenever you are dealing with that, that's the best one. Okay, fine. So hidden layers will be defined. Okay, I'll not 10, say 100. Then is not sufficient. And then let me calculate the number of words. Number of words is equal to, in the where in which variable you have the words present, it's word encoding. You can see here it's in the ENC, correct? So look at the ENC. In ENC dot words. Okay, so I will show you why I'm doing that. So directly you open and it will say that, you see, number of words. So that is 428. I just want to read it. So it's ENC dot numbers. That gives you this, and the number of classes. How do you define that? Number of classes, numerical length of, you check how many categories are there in the white train. So I'll show you the white train once. In the white train, how many categories you have, right? Mechanical, electronic, second one, leak, third one. Again, a mechanical comes, it will not calculate, software, etc. Right? So I need to do that. I need to calculate that. So numerical length of, uh, we can use categories of the y, in the y train data. Just check how many things are there. All right, let me run this part once quickly just to check for errors. No errors. Okay, let's proceed. Now I will define the various. Now, what will be the next step? Next step is you need to define the number of, what are the various layers you are going to use. Main layer will be the LSTM layer, but since you are dealing with the textual data here, you need to add a new layer called word embedding layer. Okay, that's what is new for us. We have not done that so far, right? After that, maybe you use LSTM, by LSTM, fully connected, softmax, classification layer, etc. You will use it. Okay, that will be there. And after that, we are going to provide the training options to the machine. Once you do that, then you can call the train network function to train the network. Then you go for a testing. Okay, directly you can go for a testing, and then we can give our own data to test the machine, that saying that what type of classification it's going to perform. Okay, so that's what is going to come in the next class.